This screencast from Explain Everything is going to look at in electrochemical cells, electrolytic cells. We're going to look at electrolysis of a molten salt. We've already looked at electroplating, and we've already looked at the comparison with galvanic cells. We're going to use the example of the molten salt of sodium chloride, so that as a liquid, so that has to be melted first. The melting point of sodium chloride is 801 degrees Celsius, so we need a temperature greater than that for it to be molten. First of all, we're going to set up our cell again. We're going to have some pot. We're going to have a source of electricity, whether it's a battery or a power source. And of course, we have in here a inert electrodes, both at the cathode and anode this time. And of course, it has to be electrodes that doesn't melt at 801 degrees, platinum or carbon. Will do this job. Platinum melts around about 1800 C, a little bit under, and carbon tends to decompose. So of course you need an inert atmosphere to do this under, because carbon and platinum at those temperatures could oxidize, even platinum. So you need to have an atmosphere of argon or nitrogen gas. We also need to have no water around, because effectively we're going to create the highly reactive metal sodium, and this is how it's done. First of all, we have to have it's not a solution this time. All we have in solution is sodium and chloride as the ions. They're molten, moving around. Now we're thinking about the processes that could occur. So we've got here sodium plus. The only other thing it could form is sodium metal, and we've got chloride, and the only other thing it can form is chlorine. So all that can happen here is that sodium can reduce and chlorine can oxidize. This is a reduction. This is an oxidation. Of course, that will occur at the anode. Reduction always occurs at the cathode. And we can look up at our electropotentials on page 10 of our data booklet, and we see that to reduce sodium, it takes 2.71 volts, and to oxidize chlorine, it takes 1.36 volts. So our electricity supply has to be greater than this 2.71 for the process to occur at both electrodes. Okay, so what happens? Well, the negative electrode, of course, here, the cathode, is where reduction is going to occur, and the positive terminal, the anode, is where oxidation is going to occur. So reduction at the cathode, sodium will hit this and start coating it with sodium metal, and chlorine will hit the other electrode, the anode, and start making chlorine, which bubbles off as a gas. And of course, if this is done under enclosed conditions, the chlorine can be collected, and the sodium metal under the inert atmosphere is scraped off the cathode and stored under oil to stop it reacting. Your task: see if you can create a similar cell if you've got molten, say, potassium iodide. What would happen at each electrode, and what will be produced? What will you see?